In this video, we will see about the oxidation and reduction of aldehydes and ketone. Okay, so we are going to see the oxidation and reduction reactions of aldehydes and ketones. So first, let us see about the oxidation of aldehydes and ketones. Yes, oxidation of aldehydes and ketones. So let us first take a simple aldehyde, CH3 C double bond OH. This is acetaldehyde or methanol. Its IUPAC name is methanol. Okay, so this on oxidation. So let us think about some oxidizing reagent. Okay, the oxidation will take place in the presence of some oxidizing reagents. K2Cr2O7, potassium dichromate, or we can use KMnO4, potassium permanganate chromic oxide. Okay, so these reagents can be used as an oxidizing agent. So what will happen if acetic acid is, acetaldehyde is oxidized? You will get acetic acid, whose formula is CH3 C double bond OH. Okay, so C double bond OH, this is a functional group for acids, carboxylic acids, and C double bond OH is a functional group for aldehyde. So aldehydes on oxidation gives you the acid. So we have done it with a simple example. Okay, so in this place, if we take ketone, what will happen? So actually, the oxidation will not take place under normal condition for the ketones. Okay, so under drastic conditions, that means in the presence of acid, okay, or by using nitric acids, the oxidation can occur. Even there, the ketones will be converted to mixture of carboxylic acid. So it's not that much easy as you do it for an aldehyde. Under acidic conditions, okay, so along with the oxidizing agent, the ketone can get oxidized. So if I put CH3 here, so this is acetone, okay, and C double bond O is a functional group for the ketone. Okay, the simplest ketone is a dimethyl ketone or acetone. We can also name it as propanone. Okay, 3 carbon atoms are carbons are there. So the parent hydrocarbon is propane. All right. If I convert this ANE to ONE, E as ONE, propanone. Propanone will be the IUPAC name for this ketone. So this can be oxidized under drastic condition. That means in the presence of acid. Okay, along with the oxidizing agent, there should be acid, or under acidic condition it can be done. It can be converted to acetic acid. Acetic acid, okay, so here carbon-carbon bond will break and this get converted to acetic acid. This may be converted to formic acid. So you will get a mixture of acid, formic acid, HC double bond O, OH. Okay, so now let us do it with another example with an unsymmetrical ketone. So this is actually symmetrical ketone. Now let us do it with an unsymmetrical ketone. Now we have taken an unsymmetrical ketone. Let us name this one. How many carbon atoms are there? 1, 2, 3, 4, 5. So the parent hydrocarbon will be pentane. Okay, so this is pentanone. Okay, ONE we can put. So this is at second carbon. So pentane 2O can be the name, IUPAC name for this compound. Okay, Now when this is being oxidized, so it has to be oxidized under drastic condition because it's a ketone. That means under the presence of acid along with an with the oxidizing agent. Okay. So this when oxidized, where the cleavage may occur. So that's a question here. The cleavage occurs at carbon-carbon bond so that the keto group, that is C double bond O group, stays with the smaller alkyl group. So that means we should not cleave it here. Okay, cleavage doesn't occur here. So when we take an unsymmetrical ketone, cleavage occurs at a carbon-carbon bond so that the C double bond O stays with the smaller alkyl group. Okay, so this rule is said to be Pope-App rule. Pope-App rule. Okay, all right. So if the cleavage occurs here, then what are the two kinds of acid mixture you get? You get CH3, CH2, COOH, and then CH3, COOH. All right. CH3, CH2, C double bond OH. It can be named like propanoic acid. 3 carbons are there, so propanoic acid. Okay. So this comes from this carbon chain, propanoic acid. And then you also get acetic acid, CH3, C double bond O, OH. So you get a mixture of propanoic acid and acetic acid. So when you get an take an unsymmetrical ketone, what kind of mixture of acids you get is determined by the Pope-App's rule during oxidation. Okay, it states that during oxidation of unsymmetrical ketone, the carbon-carbon cleavage occurs so that C double bond O stays along with the smaller alkyl group. Now we will see reduction of aldehydes and ketones. Just now we saw about the oxidation of aldehydes and ketones. Now we'll see about the reduction of aldehydes and ketones. So what happens when we reduce aldehydes and ketones? 3 kinds of products may be produced. Okay, so that depends upon the reducing reagent you are using. Okay, so it may end up with the formation of alcohols. Okay, that is, when you reduce aldehydes and ketones, you may get alcohols. Secondly, you may get hydrocarbon. Thirdly, you may get pinacols. Pinacols means symmetrical diols. Okay, so these are the 3 kinds of product you get when you do the reduction of when you reduce the aldehydes and ketones. Okay, so that depends upon the reagents. For example, when you use lithium aluminum hydride, sodium boron hydride. So when you use these reagents, so actually reduction means addition of hydrogen. So when that is done in the presence of lithium aluminum hydride and sodium boron hydride, you get alcohols from the aldehydes and ketones. Okay, so when you use some Clemmensen reduction reaction, reducing agent, Clemmensen reducing agent will be a zinc amalgam. Mixture of zinc and mercury is zinc amalgam and concentrated hydrochloric acid. So this mixture is a Clemmensen reducing agent. And then if you use Wolff-Kishner reducing agent, Wolff-Kishner reducing agents are mixture of hydrazine, NH2 is hydrazine, and C2H5ONe, sodium ethoxide. So this is Clemmensen reducing agent. This is Clemmensen reducing agent. This is Wolff-Kishner reducing agent. So zinc amalgam and concentrated sulfuric hydrochloric acid is Clemmensen. Wolff-Kishner is hydrazine and sodium ethoxide. When you use either of this Clemmensen or Wolff-Kishner reducing agent, the aldehydes and ketones are getting converted to their corresponding hydrocarbon. So pinacols. Pinacols means symmetrical diols. 2 OH groups will be there. To get pinacols, it is to be reduced in the presence of mercury and magnesium, that is magnesium amalgam, followed by hydrolysis. Okay, I think it's clear now. Reduction of aldehydes and ketones may end up with 3 kinds of products: alcohols, hydrocarbons, pinacols. If you use lithium aluminum hydride and sodium boron hydride as reducing agent, you get alcohol. When you use Wolff-Kishner and then Clemmensen, this is Clemmensen, okay, Clemmensen, Wolff-Kishner reducing reagents, or so when you add the hydrogen in the presence of such kind of reducing reagents, you get hydrocarbons from the aldehydes and ketones. You get pinacols, that is diols, symmetrical diols. When you use magnesium amalgam followed by hydrolysis for reducing the aldehydes and ketones, okay, you get pinacols. Now let's try all this. So let us take now the basic aldehyde, that is CH3 C double bond OH. What is this? This is acetaldehyde. Reduction means addition of hydrogen, okay, in the presence of lithium aluminum hydride, okay. So aldehydes and ketones, when they are reduced in the presence of lithium aluminum hydride, you get alcohol, okay. So this hydrogen, let us combine one of the hydrogen with oxygen and one of the hydrogen with carbon. Then what do you get? CH3 CH, and we do have this H here, okay. So it becomes CH2. So CH2, and then you are going to add one hydrogen to the oxygen, okay. So one hydrogen from this H2 is added to carbon and then the oxygen, and double bond has to become single bond. Then you get CH3 CH2 OH. So that's what I'm writing here, CH3 CH2 OH. So what is this? Ethyl alcohol, okay. So acetaldehyde, on reduction in the presence of lithium aluminum hydride or sodium boron hydride, you get an alcohol. So this is the primary alcohol. So what do you mean by primary alcohol? The OH group, the carbon, if it contains 2 hydrogen atom, okay, the carbon which is attached to OH, if it contains 2 hydrogen atom, it is said to be primary alcohol, 1 degree alcohol. The carbon attached to OH group, if it has 2 hydrogen, then it is said to be 1 degree alcohol. The carbon attached to OH group, if it contains only 1 hydrogen, then it is said to be secondary alcohol, 2 degree alcohol. The carbon attached to oxygen, if it does not have any hydrogen, okay, if it is attached to methyl group alone, 3 methyl group alone, not the hydrogen, if it does not have the hydrogen, then it is said to be 3 degree alcohol. So acetaldehyde, on reduction in the presence of lithium aluminum hydride or sodium boron hydrate gives you the 1 degree alcohol. Now let us take acetone. Okay, CH3, C double bond O, CH3. Hydrogen in the presence of either lithium aluminum hydride or sodium boron hydride. So, even in this case you get the alcohol. Just add one hydrogen to carbon and one hydrogen to oxygen. Okay, and the double bond has to be changed to single bond. Then what do you get? CH3, C, CH3. Okay, one hydrogen is added here. One hydrogen is added to oxygen. Don't put double bond here. Okay, now this is a kind of 2 degree alcohol. Okay, the carbon attached to OH has got only one hydrogen. Then this is said to be 2 degree alcohol or secondary alcohol. Isopropyl alcohol. Iso meaning is branched. So it's a branched one. And 3 carbon atoms are there. So isopropyl alcohol. So isopropyl alcohol is a kind of secondary alcohol. So this one is ethyl alcohol. So acetaldehyde on reaction with lithium aluminum hydride gives you the primary alcohol, ethyl alcohol, and ketone, that is acetone. Okay, acetone on a reduction in the presence of either lithium aluminum hydride or sodium boron hydride uses secondary alcohol, namely isopropyl alcohol. Alright. Now in the same case, let's use zinc amalgam. Zinc amalgam means mixture of zinc and mercury. Concentrated hydrochloric acid. So this is actually Clemmensen reducing agent. Clemmensen reducing agent. So when you use Clemmensen reducing agent, what will happen? Aldehydes and ketones will be converted to hydrocarbon. Hydrocarbon means they contains only carbon and hydrogen, not oxygen. So what happens is the C double bond O will get converted to CH2. Okay, C double bond O will get converted to CH2. So you get CH3, C double bond O is converted to CH2, and you have one more hydrogen here. So what do you get? CH3. Now it has been converted to hydrocarbon. Hydrocarbon contains only carbon and hydrogen. So what is the CH3? CH3? It is said to be ethane. Alright. So when you take acetone and reduce using Clemmensen reducing agent, that is zinc amalgam and concentrated hydrochloric acid, C double bond O gets converted to CH2. Then you get CH3, CH2, CH3. You are getting its corresponding hydrocarbon, that is propane. So this is ethane, this is propane. So in the same way, if we use Wolff-Kishner reducing agent, also you get the same product. Acetaldehyde to ethane and then acetone to propane. So what is the Wolff-Kishner reducing agent? Hydrazine, NH2, NH2. It's a mixture of hydrazine and sodium ethoxide. This is ethyl group, sodium ethoxide. Alright. This is said to be Wolff-Kishner reducing agent. So when we use Clemmensen and Wolff-Kishner reducing agents, the aldehydes and ketones are reduced to their corresponding alkane or corresponding hydrocarbon. So pinnacle formation. For pinnacle formation, magnesium amalgam. Magnesium amalgam followed by hydrolysis. Okay, MgHg hydrolysis. But I don't think you get it from aldehyde. you get it from pinacol, you get it from ketones. Okay, so for this you have to write the ketone. So let us write the acetone in this form. Okay, acetone, this is acetone. So another acetone also I am writing in the same way. So 2 molecules of acetone reduced. Reduced means addition of hydrogen. Hydrogen in the presence of magnesium amalgam. Okay, followed by hydrolysis. Just you have to join these two carbon. Join these two carbon and put one hydrogen to one of the oxygen and another hydrogen to this oxygen, and then combine. You get a symmetric alcohol. So let us write that now. CH3, C, CH3, two carbons are bonded. Okay, and hydrogen is given to this oxygen and another hydrogen given to this oxygen. So you get a symmetrical dia. OH groups are on the same side. This is said to be a pinacol. 2,3 dimethyl. 1, 2, 3, 4. So butane 2,3 diol. 2,3 dimethyl butane 2,3 diol. This is a kind of pinacol. So we have seen the reduction of aldehydes and ketones too. Okay, so first we have seen about the oxidation of aldehydes and ketones. Then we have seen various kinds of reduction of aldehydes and ketones.